This recording is for the trig functions on unit circles lesson in Unit 5. So some things to remind yourself of are the unit circle and how that works, degrees versus radians, and then we're looking at trig functions, so sine, cosine, tangent, cotangent, secant, and cosecant. So it starts out with a little table that gives you some information about some common angles. So like pi over 6, pi over 4, and pi over 3. And then we know that pi over 6 is really 30 degrees. And pi over 4 is 45 degrees, and pi over 3 is 60 degrees. And then we want to look at the top three functions. So sine, cosine, and tangent for these common angle measurements. So the sine of 30 degrees is 1/2. The sine of 45 degrees is the square root of 2 over 2. And the sine of 60 degrees is the square root of 3 over 2. The cosine of 30 degrees is the square root of 3 over 2. The cosine of pi over 4 is square root of 2 over 2. And the cosine of pi over 3 is 1/2. The tangent of pi over 6 is the square root of 3 over 3. The tangent of pi over 4 is 1. And the tangent of pi over 3 is the square root of 3. So these are definitely useful to reference, but I would suggest putting these into memory, especially if you plan on going forward into calculus. Alright, so some example problems. One of them says use the diagram given to, let's draw the diagram first, O, H, and A. So we want to use this diagram to derive and prove the Pythagorean identity based on sine and cosine. So the Pythagorean identity is where sine squared theta plus cosine squared theta equals 1. And what we're trying to do is use this diagram and this Pythagorean identity to turn it into what we would know as the Pythagorean theorem. So what we do is we replace the sine and cosine with the trig functions and their ratios based on the diagram. So if that's theta, then sine is opposite over hypotenuse. So this would be O divided by H squared. And cosine is adjacent over hypotenuse. So that would be A over H squared equals 1. Now we want to simplify. So that becomes O squared over H squared plus A squared over H squared equals 1. But we don't like fractions, so if we multiply this entire thing by H squared, we're left with O squared plus A squared equals H squared. Now notice H is the hypotenuse, so I have the two legs squared added together gives us hypotenuse squared. So even though it's different letters, it's still A squared plus B squared equals C squared. Alright, next, find secant theta if theta is in quadrant 4, and the sine of theta is negative 1/5. So again, in these types of situations, if it helps to draw a picture, then go for it. So we know it's in quadrant 4. So we have a triangle built in to quadrant 4. And then right here is theta. And it says the sine is negative 1/5. And so sine is opposite over hypotenuse. So opposite is 1, negative 1, because notice we're going down, and the hypotenuse is 5. So by using the Pythagorean theorem, we can figure out the third side there. And the third side is going to be 2 square root 6 when all said and done. So we want to find secant. Well, remember that secant is really 1 over cosine. So we're looking for cosine of theta. So if we're finding cosine theta, cosine is adjacent over hypotenuse. So that would be 2 square root 6 over 5. But we want 1 over that. So we have 1 over 2 square root 6 over 5. But remember that the fraction bar means divided. So we have 1 divided by 2 square root 6 divided by 5. We never actually divide, we flip and multiply. So we get 5 over 2 square root 6. But remember, we don't have radicals in the denominator. So we need to take the 5 over 2 square root 6 and multiply top and bottom by the square root of 6 to rationalize our denominator. So now we have 5 square root 6 over 2 times 6, which gives us 5 square root 6 over 12. And so the secant theta is equal to 5 square root 6 over 12. Next, find the exact value of tangent of 5 pi. So again, remember, if we look at our unit circle and we count by pi's, that from here to here is pi, and then if we include this, now we're at 2 pi. If we go again, then that's 3 pi. Again, that would be 4 pi. One more time would be 5 pi. So what we notice is that 5 pi is going to be coterminal with pi. So I can change this to say the tangent of pi, because it's going to be identical. The tangent of 5 pi is going to equal what the tangent of pi is. And you can either use your calculator or figure it out, either way. But the tangent of pi is 0. So the tangent of 5 pi is also 0. Next, find the exact value of the cotangent of 7 pi over 4. Now again, if it helps to look at your unit circle again, we can count by pi over 4s. So pi over 4 again is 45. So here's pi over 4. Next pi over 4 would be here, and then here, 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 here. So we count. So 1, 2, 3, 4, 5, 6, 7. So here's where 7 pi over 4 is. And then we see that it's just going to be the negative of what pi over 4 is. So in this case, we know that cotangent has to be cosine over sine. And if we look back at that chart, cosine and sine of pi over 4 was square root of 2 over 2. But we're on the negative, so we have negative square root 2 over 2 divided by the square root 2 over 2, but that just leaves us with negative 1. Next one, explain how to find the exact value of the secant of 13 pi over 4 and what quadrant it's in. So again, if we look at counting by pi over 4, I'm just going to highlight where they end up. And so let's count them off. So we start here with 1 pi over 4, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 pi over 4 sits in the third quadrant. And so with this being the third quadrant, we know that it's going to be, secant is 1 over cosine, and cosine here is going to be negative cosine because of the quadrant. So the negative cosine of pi over 4 is going to give us the same result as just finding 13 pi over 4. And so we know that the cosine of pi over 4 is square root of 2 over 2. So it's going to be negative square root 2 over 2. But we want secant, so it's 1 divided by negative square root 2 over 2. So it becomes 1 times negative 2 over square root of 2. We have to rationalize our denominator. When all said and done, our answer is negative square root 2. Final problem. Find the exact value of the tangent of 2 pi over 3. This one's a little trickier. We can count by this, meaning if we count by pi over 6's, we can get there. And so in our quadrant, we know that we'd have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and so on. But if I reduce this 4 pi over 6, that becomes 2 pi over 3. And so we're looking at this one right here. So we're in quadrant 2. And we know that our reference angle is pi over 3. Right? So we could have done this counting by pi over 3's as well. Just wanted to show you a separate avenue on this one. So our reference angle is pi over 3, and so we need to know what the cosine and sine are for pi over 3. And so we look back at that chart, so it's the square root of 3 over 2, and then we're going to have to divide that by 1/2. So sine over cosine. And so that's the square root of 3 over 2 times 2 over 1. And we're in quadrant 2, so our x value is negative. And so now the 2's cancel, so our answer is the negative square root of 3. So that's the end of this recording. Now you'll just need to phone, text, or Skype message me so I can ask you a couple of questions and you can get credit for this Class Live assignment. Have a great day.